All right, moving on to graphing linear inequalities. All right, when it comes to graphing the solution for a linear inequality, we have two things that we have to do. One is to graph the boundary line, and two, we need to shade one side of that boundary line, indicating where the solutions lie for the linear inequality. Now, earlier we talked about how graphing lines is much easier when we can identify the slope and the y-intercept. All right, so what we can do here is with this inequality, change that inequality symbol to an equal sign, and then quickly recognize that we're looking at an equation that's in slope-intercept form. All right, again, this is going to allow us to graph our line accurately and quickly. All right, so here we've graphed our line with a y-intercept of 2 and a slope of 3 over 2. All right, here we have a solid line, which now we need to figure out what side of that solid line to shade. So we're going to figure that out is by using a test point. Now we can use any point we want as a test point for the inequality, as long as it's a point that does not lie on our boundary line. And usually if the origin is available, we like to use the origin. Okay, so we see definitely that the origin is available. It's on this side of the line. So we're going to use that as our test point. Going back to our original inequality, we're going to plug 0 in for x and 0 in for y. And we're going to simplify that right side to see what we're left with in terms of the inequality statement. And when we simplify that right side, we're left with a statement that says that 0 is less than or equal to 2. Now, since that statement is true, that means we know that 0, 0 is a solution for the inequality. And because 0, 0 and that test point lies on, could be considered the bottom side of that line, we know that every point that is on that same side of the test point will also work. So that is going to be the side of the line, boundary line that we shade. Okay, so again, where we shade, we are saying that this is where all the ordered pairs, all the solutions for the linear inequality will lie. Let's move on to example number 3. Again, we may want to consider changing that inequality to an equal sign, giving us a better chance of graphing this boundary line with a higher degree of accuracy. So again, I went ahead and graphed my y-intercept at 2. And using the slope down 1 over 1, I found additional points to graph my line. Now you notice I did not connect the dots yet, because for this inequality, we need to make sure that we connect our dots with what's called a dashed line. So the reason why we use a dashed or a broken line is because the original inequality does not have the or equal to option. It's just less than. Okay, so whenever you have an inequality symbol like this, whether it be less than or greater than, you need to make sure you use the dash or the broken line. Going back to example number 1, again, we graphed a solid line, a normal looking line. Again, for this, it's because the inequality has the or equal to option. Okay, so again, if you have the or equal to option in your inequality, you're going to be graphing your boundary line as a solid line. Again, if it doesn't have the or equal to, your boundary line is going to be dashed. Okay, so now again, we're going to have to figure out what side of that boundary line to shade. So again, we're going to pick a test point, like the origin, 0, 0, and use it to be plugged into the inequality and see what sort of inequality statement we're left with. So here again, we're left with a statement, 0 is less than 2, and that's a true statement. And because the test point, 0, 0, gave us a statement that is true with respect to the inequality, that means that it is a solution, and the side of the boundary line that it lies is a side that contains all other solutions. Now, conversely, if we did use the test point and it did not work for the inequality, then we would have to shade the other side. So again, when it comes to figuring out what side to shade, one of the two sides is going to be the side that's going to get shaded. Again, we're going to use a test point to determine whether the test point is the side that contains the solutions or not. Let's move on to example number 5. So here we're looking at, again, a linear inequality, which we have to, again, graph the boundary line and figure out what side of that boundary line to shade. So again, we may consider changing that inequality to an equal sign to bring us to a more familiar situation. So here we want to graph this linear equation. Now, an alternative way of graphing a linear equation in standard form is trying to find the x and the y-intercepts. Now, this method is helpful, especially when you notice that the leading coefficients of your variables easily divide into the constant. So we're going to go ahead and find the x-intercept for this line. And we know that for an x-intercept, we know that the y component of the ordered pair is going to have a value of 0. So we just need to find that x component. So when we plug 0 in for y, we're going to be solving for x. So by plugging 0 in for y, that knocks out that term in the equation, leaving us with 5x equals 10. And solving for x, we get x equals 2. So there is our x-intercept. It's at 2, 0 on the coordinate plane. Now I want you to see if you can figure out where the y-intercept is. Let's see how you did. Now again, the y-intercept has an ordered pair where the x-coordinate is 0. So we're going to be plugging 0 in for x in our equation. So now again, plugging 0 in for x essentially knocks out that term from our equation, leaving us with negative 2y equals 10. Solving for y, we get y is equal to negative 5. So that's the location of our y-intercept at 0, negative 5. All right, so now that we've identified our x and y-intercepts for our boundary line, we're going to go ahead and connect these 2 points on our graph grid. Again, realizing that our inequality is just a greater than, it does not have the or equal to option. That means that our boundary line is going to be dashed. Now we need to figure out what side of that boundary line to shade. Again, since the origin is available, we're going to use the origin as our test point. So now you notice when we plug in 0, 0 in for x and y in our original inequality, we are left with a statement that states 0 is greater than 10, which we all know is not true. And because our test point gave us an inequality statement that is not true, then we know that that test point is not a solution. And that also means that every point that's on that same side of that boundary line is also not a solution. Therefore, the solutions for this inequality are going to lie on the side that does not contain the test point. So this is the side that we're going to shade. Okay, because our test point did not satisfy, did not work for the inequality, then we know that it is not a solution. We know that that side that it lies does not have the ordered pair solutions that work for the inequality. Therefore, we're going to shade the other side. Okay, that's it for today. Move on to the day 1 homework.